The laws of physics are supposed to be universal. That is one of the foundational assumptions of all of science. That the rules governing matter, energy, space, and time are the same everywhere and at every moment in history. That what holds true in a laboratory on Earth holds true in a galaxy 10 billion light years away. That the constants, the speed of light, the gravitational constant, the strength of the fundamental forces, do not change depending on where or when you are. They are fixed. They are universal. They are the bedrock on which every equation ever written has been built. In 2026, the James Webb Space Telescope delivered data that put serious and undeniable pressure on that assumption. Webb was designed to observe the first galaxies forming after the Big Bang, when the universe was only a few 100 million years old. What it found, confirmed across multiple deep field surveys in 2026, was something physicists are openly calling a crisis. Galaxies that should not exist. Structures so massive, so fully formed, so mature in a universe that was barely an infant, that the standard model of cosmology has no explanation for how they got there. This is not a small discrepancy. These galaxies are not slightly larger than models predict. Some are comparable in mass to the Milky Way, fully assembled in a universe that was less than 5% of its current age. The physics we use to describe how gravity pulls gas into stars, how stars accumulate into galaxies, how galaxies grow over billions of years, those processes, at the absolute maximum efficiency our models allow, cannot produce what Webb is seeing. The numbers do not work. The timeline does not work. Something is fundamentally wrong with our picture of the early universe. There are several possible explanations. Dark matter may behave differently in the early universe than our models assume, clumping faster, seeding structure earlier. Star formation may have been radically more efficient in ways our models have not captured. The initial conditions after the Big Bang may have been different from what we assumed, or the laws of physics themselves were different, not broken, not absent, different. Some theoretical frameworks allow the fundamental constants, the values that govern how matter interacts, how quickly structure forms, how gravity operates at cosmic scales, to vary over time, to have been different in the first billion years than they are today, to not be constants at all, but parameters that slowly evolved as the universe aged. If that is true, then everything we have measured, every law we trust, every constant we rely on, applies to this era of the universe, not to all eras, not to all places. We may have only ever studied one version of physics, the version that happens to exist right now. The 2026 Webb data has not resolved this. It has deepened it. Physics may not be universal. It may be local. It may be temporary. And we may have only ever seen one version of it.